So for example number 5, it says, how many times more severe is a 2001 earthquake in India, and it had a rating on the Richter scale of 7.9. Now this occurred in 2001 in India, and then in Athens there was a Richter scale of 5.9, and that happened in 1999. And so let me read the question exactly as it's worded in the book. I won't write it down. You guys could open up your book to page 324 and just read it along. It says, how many times more severe was the 2001 earthquake in India that had a Richter scale rating of 7.9 than the 1999 earthquake in Greece that was 5.9? And so the model, a Richter scale model, is based on a logarithmic function. And so the severity of the earthquake is measured and associated with an amplitude. And so what we're going to do, this is where the log stuff comes in, we're going to let A sub 1 be the amplitude, A sub 1 and A sub 2 be the amplitudes of the earthquake, and we'll explain what amplitude is in a second. 2. And so amplitude, things have a tendency to oscillate. All right, so what happens with an earthquake is when the earthquake hits, it goes like this, boom, and there's some shaking. Well, that's called an oscillation. And if we were to measure that shaking, it has an amplitude. The amplitude is the upper and lower boundaries. Think of a trig function. That's the best way to describe amplitude. If we were to graph, say, the sine function, now the sine function goes on like this forever in both directions. But the amplitude is like the minimum and maximum values that it can have, right? So this is the amplitude. And so it's like a boundaries. And so when we talk about measuring Richter scales, we have that Richter scale 1 is equal to the log of A sub 1 over t, which is time, plus b, and that's equal to 7.9. And R sub 2 log A sub 2 over t plus b is equal to 5.9. And so what we're really trying to determine is we're trying to get the ratio of the amplitudes. And because of the way that the Richter scale rating is calculated, right, we're going to have to do some fancy math. So what I want to do is I want to take these two equations and put them together in some sort of way so I could create a ratio of the amplitudes of the earthquake. Does that make sense to you guys? So I'm going to say R sub 2. Well, let's just find the difference of them. So if I say, why isn't that working? I step on my cord and it accidentally unplugs it. There we go. Now it'll work. So if I say R sub 1 minus R sub 2, just to find the difference of the two, and then I plug in these equations, right? Well, that's going to be log A sub 1 over t plus b, right? Minus log A sub 2 over t plus b. Is that right? You guys agree with that? Do you concur? Now, I know that r sub 1 has a value of 7.9 minus the 5.9. And over here, if I distribute this negative sign through the parentheses, I'm going to get negative log of b, log of a2 over t minus b, right? Because we're distributing that through both terms in the parentheses. So then the rest of this is just going to be log a sub 1 over t plus b. And what happens is that the b's cancel, right?
Yes.
You guys with me so far? Let me slide that up there so you can see it. Oops, slid it up a little too high. You guys with me so far? So now 7.9 minus 5.9 is 2. Hey, that's easy. And now I've got log base 10, right? We don't write the 10 down, but it's there. Minus log a2 over t, right? Can I do anything with that stuff on the right-hand side to clean it up a bit? Isn't that quotient rule? In other words, could I say log, because it's all log base 10, right? We don't write it down, but we know that there's a 10 that goes there. The common log has a base of 10. And when we subtract them, I could put this on the top, right? All over this on the bottom. Can I do that? Isn't that one of the properties? Does that make sense? Now, a little side note, if I have a sub 1 over t divided by a sub 2 over t, how do you divide by a fraction? How do we do that? Multiply by the reciprocal. So really what I have is I have a sub 1 over t times t over a sub 2. Hey, don't the t's cancel? So I got a sub 1 over a sub 2. Whoops, I wrote the 2 too big. Subset notation. So all of this is what? It's the same as did it twice. And remember that this is base 10. Not too shabby. Does that look right to you guys? All right. Now my goal was to get a sub 1 and a sub 2 because we wanted to somehow find the ratio of the amplitudes of the earthquake based on these Richter scale scores. So I think I might be able to do that if I remember that y equals log base b of x is the same as b to the y equals x, right? Is that right? So in this scenario, what's my y term? Y equals 2. What's my b term? My base is 10. And what's x? A sub 1 over a sub 2. So if I rewrite this, I would say what? Yes? 10 squared equals x, which is a sub 1 over a sub 2. Gosh, why do I keep doing that on the second one? So I get 100 is a sub 1 over a sub 2. Now remember, this is the amplitude of India. There's an earthquake in India. And this represented the amplitude of the earthquake in Greece. What is that saying? Here's what we got to think. So what was the amplitude? The Richter scale R sub 1 was equal to 7.9, right? And this one here, R sub 2, the Richter scale gave it a 5.9. But with regards to the amplitude of the earthquake, what does that tell us about the strength when we compare the two? Yes? Yeah. That is exactly correct. The earthquake in India was 100 times stronger. Based on the amplitude. Does that make sense? So when they have an earthquake and it's like an 8 or a 7 and it does a lot of damage, and then here in the Midwest where we live, I think we had an earthquake like, oh, when I was a kid, I remember when it happened, we had an earthquake, it was like a 5 or something. You barely noticed it. It felt like you could barely feel it. So if we had a 5.9 here in the Midwest, it's not anywhere near as the ones that they have on the West Coast in California. Because those, that one they had in San Francisco, I think that was in the 7s. So the one they experienced is 100 times higher than ours. Does that make sense? Any questions on the math, though? You'll have a homework problem like that. In fact, look at example number 45. You guys see it's on page 331. You would do the exact same thing.